So today we are having fourth day school. Today I want to discuss software testing, verification, validation, testing strategy, and software maintenance. Can you tell me what is programming error? We can call it as a bugs. The process of finding them and correcting them is called as debugging, right? So there are mainly three type of programming errors are there. So first one is syntax error. So normally when you're coding, you know what is a syntax error, runtime error, and semantic error. So syntax error, any programming language can execute a program only if it is written in correct syntax. If you have missed any syntax for particular language, you will get syntax error. And example for syntax error, yes, if you missed a semicolon in your program, and if it is compulsory to have it in your program, you will get the syntax error. Yes, if you have missed any bracket which is necessary to have it in your program, you will get uh, syntax error. So you have an idea about the syntax error. And next type is runtime errors. So it will appear once the program start running. So those are called exception. So most probably you will get these runtime errors. So can you give me an example for that? Yes, dividing by zero. Yeah, if you have performed any illegal operations in your within your program, so you will get some runtime error. So most probably you will see these runtime errors when you are doing Java. With NetBeans, you will get some, if you have some inapplicable things in your program, you will get this kind of thing. So, and last type is semantic errors. So those are the logical problems in a program. If there is a there is a semantic error, most probably the program will not give an error message, but it will give wrong output. So, do you have any idea about semantic error? So, can you tell me any example? Yes, yes, you will get and semantic errors when you haven't declared a variable and you are using those variables inside your program. So in that case, you will get some semantic errors. And yeah, okay. Now matching of actual argument with the formal. Yes, if you have that kind of things, also you will get some semantic errors. So now those are some programming errors which we are dealing with. So my next question is, what is software testing? Testing the written programs of a software before handed over to the client. In software testing, what we are doing is we are going to detect our faults and we are going to remove all the faults in our program. So it's a method to check whether the actual software product matches expected requirements. So during earlier day schools, we discussed about the software requirements. So in this stage, in this software testing stage, what we are going to do is we are going to check whether we have met the client requirements. So right. So this is the step which we are going to informal definition in the process of evaluating work product, not the actual final product of a development phase to determine whether they met specific requirement for that phase. Actually, in the verification stage, we are going to check, are we building product right? In the verification, we are going to check whether we are building product right. So this is the most important thing, right? Product right. So for that, we can use evaluation items as plan, requirement spec, design spec, code, test cases. Those are some evaluation items related to this verification. So next thing is validation. So in the validation, right, in the validation, the process of evaluating software during or at the end of the development process to determine whether it satisfies specific business requirements. So earlier in the verification, we check whether we have in the validation, we are going to check whether we build the right product, right? So in the verification, we are going to check whether it's a we are going to build the product in right path. Clearly, I understand the difference, right? Let me go to that. So here in verification, are we building the product right? So in the validation, we are going to check whether build are we building the right product. For the validation, we can have actual product or software as evaluation. So this is the testing in various stages of this is the life cycle for the software testing, right? So I think you're familiar with this this part for this process. So now first we are just to remember. So first at the first stage we are going to get client or your customer requirements. So then we are in the structural design. So then we can detail design. So after doing all these things, so now we have developed our product, right? So after developing your product, so this is the place where we start our testing, right? So to start our testing, so first thing is we are going to perform unit test. What is unit test? We can call this unit test as let's say this is quite large project. So we are going to divide. We have divided this specific project into small units, right? So then we have developed it, right? So in this unit test stage, we are going to check each and every unit or module separately. The purpose of testing for these modules is to ensure that we have achieved the customer requirement. For that, we are going to check each unit, or we can call it each module. And here we are going to verify the module design as well. So after performing unit test, we can move to the integration testing part. So here in the first stage, every single module. So in this stage, we are going to integrate. After in this stage, we are going to integrate that, and as a whole system, we are going to test. So at this stage, at the unit test stage, we verified that these each and every units perform correctly, but they perform correctly as a single module. As a single module, these parts are performed very correctly. We check it during this stage, right? So then we have to integrate. So no use having these modules separately. So customer want all these things in one product. So for our use easiness, we divided into the small parts. So we code it as a small part, and in this stage we test it. So then in the next stage we are going to integrate that. So integrate, and then we have to check although these modules perform correctly in the separate, we have to check whether it's fit to our whole model. Once we integrated all these things, we have to check whether these are performing well as the one unit, right? So that's why we are having integration and test as the next step. Is it clear about unit and integration? We can move to the next stage of this life cycle. So that is acceptance testing. Here also we are going to check the complete system to verify the requirements of real use. In this stage, we are going to test our system using real data, and also we can after test this system using real data, we can release our product to we can release our product to the market or the somewhere for the purpose of testing. So we can, let's say you are going to develop let's say you have developed a game. So now you have tested by yourself, but more clarification you are going to give this game for some people, for few set of people to check whether when they are using that game, they can check while playing your game, they can check if it is performing well or not. So that's what we are doing in this acceptance test stage. So then I'll move to the testing strategies. So mainly we are having two main strategies. So first, not two, mainly three testing strategies. First one is black box testing. So mainly we are using this. Mainly we are using two strategies: black box and the white box testing strategies. And there is another one which is gray box. So most widely we are using black box and white box. So what is black box testing? Okay, test cases are derived from the requirements without reference to the code itself or its structure. Mainly focus on inputs and outputs of the software application. Right. Here you can see test cases are derived from the requirement without reference to the code itself and the its structure. Can you tell me, if I don't have any knowledge about coding, can I perform black box test? Let's say I don't have any idea about the coding for this particular system. So can I perform black box testing? If you don't have any idea about, let's say you are going to test this system, right? But you don't have any idea about this system coding, but you can perform black box testing. That's why we are telling it black box. It's like we are blind. We have no idea about the system coding, but you can perform this black box testing, right? Uh, that is the important thing when you are going to perform black box testing. So you can perform this test without having knowledge of internal code structure and implementation details, and also internal part of this system, right? So is it clear? Without having any knowledge about this system coding and system implementation part or internal part, you can perform black box testing. It's like you're blind. So you cannot see anything, but you can perform this. So there are some techniques that we can use to perform black box testing. So so there are mainly two. There are mainly two black box testing techniques. First one is equivalence class testing. We can call it as the equivalence partition testing. So what happens if we use this technique? Equivalent class testing. It is used to minimize the number of possible test cases to an optimum level while maintains reasonable test coverage. In this technique, you're going to divide your input data units into equivalent partitions. Those partitions can be used to derive test cases, and those test cases will reduce time required for the testing, because here we are having small number of test cases. When you are going to perform this technique, first you have to divide your input into partitions. Then you can test your system using this. So can you tell me an example for equivalent partition or equivalent class test? Okay, let's say in your system you have a date field. So now we are going to check this date field, right? So that means we are having 1 to 31 dates now per month maximum, right? So this date field should be within this 1 to 31. So is it clear? Can you hear me? There is a heavy rain. So we are going to check date field, right? Date should be within 1 to 31. Right. So I'm going to use this equivalent class testing to check this date field. So I'm going to have some test cases, right? First, I'm going to check some invalid thing, right? So first I want to check these values like 0, -1, -2, likewise, right? That is my first test case. And the second one, it's a that is in valid range. I'm going to check whether it's between 1 to 31. Then I'm going to check again invalid thing within 32 onwards. I mean 32 greater than 30, 31, 32, 33, 34, likewise. Right, those are my 3 test cases. So now I'm going to check my date. So here you can see we have some test cases. So in this case, I have 3 test cases and we have divide. So these are the numbers that we can input to our system as an input value, input data, right? So I have divided my input values into three sections or three partitions, or we can call it as three classes. So first I'm going to check this these kind of a values. If I put 0 as a date, what will happen? So I'm going to check this date. I'm going to test this date field. If I put 0 as a date, what will be the output? Yes, we will get an error. So this is not these values are not in the correct range. So these are some invalid range. If you give these values, system must reject your values and it should show you some error message, right? So then I'm going to check this second test case. So here I'm going to give a value between 1 and 31. Let's say I will give 12, right? If my input is 12, what will be the output? If I test this date field with input 12, what happens? What will, right? So it says it's correct or something, right? So this system will accept this value as a correct input. If you give these values, system will reject your input. But in this case, your system will accept any value between not with including this 1 and 31, with including these two values, it will accept your value as a correct input. Then I'll move to next case. So if I give any values greater than 31, which means starting from 32, this system will reject it. This is, system will not accept my value as a correct. So is it clear? Okay. Can you tell me another example for this equivalent class testing? Let's say you're going to so let's say you're having some login page, and for the password field you need at least 6 to 10 characters, right? For the password you need 6 to 10 characters, right? So as a valid range, as an invalid range, I'm going to check, uh, since this is a character, I'll I'll check with 0 to 5 as a first case, and then I'll check it with 6 to 10. Then I'll check more than 10 values. More than 10, right? So this is also same as this. So you can give some characters between 0 to 5. So in that case, your system will not accept your password as a correct. So if you give a password between 6 to 10 characters, system will accept your password as a valid password. So if you give a more than password as more than 10 characters, so again system doesn't accept your password as a correct input. So again it will reject, and you have to give give characters within the correct range. So is it clear? Right. That's about equivalence class testing. Right. So next thing is boundary value test. Boundary value testing is focused on the values at boundaries. This technique determines whether a certain range of values are acceptable by the system or not. It is very useful to reducing the number of test cases it is most suitable for the system where an input is within certain range, right? In the boundary value testing, we are going to test our system with boundary value. Let's say I'll take my first, I'll take this take example for the boundary value. So our range should be within 1 to 31. Date should be within 1 to 31. So here in the boundary value testing, we can lower range and the upper, right? So here I'll put this 1 to 31, right? So first I will take lower part. Lower part means you can get before value and that. Then as a uppercase, right? We have 31 and as a boundary, we can get 32, right? So we are have this one will go for the lower section. This 31 will consider as the upper case. So if you give 0 as an input data for the date field, system will reject your input. And if you give 1 as the input, system will accept your input. And in the upper case, if you give 31st as your date, system will accept, right? Then if you give this 32nd as a date, system will reject. Can you see the difference between these two techniques? So here we are having some range of data and we can give any value between that range. But when it comes to the boundary value, we are considering only this. So here we are test both side of boundaries. And for these characters example, if you perform this boundary value, so here you have two test cases, lowercase and the uppercase, right? So in the lowercase, we can have, so here we are considering 6 and 10, right? For lowercase, we can have 5 characters, or we can have 6 characters. For the uppercase, we can have 10 characters, or we can have 11 characters as an input. So if you give 5 characters for this password field, system will reject. This is not satisfying your requirement. So if you give 6 characters, system will accept. And if you give 10, system will accept. If you give 11, system will reject. So that's how we can perform these two black box testing techniques. So is it clear about these techniques? Then I'll move to the next one, next testing strategy, white box testing. So in white box testing, detailed investigation of internal logic and structure of the code we can call it, we have few names for the white box testing. So we can call it as a glass testing or open box testing. Uh, and also we can call it as the clear box, transparent box testing, or code based uh, testing. Likewise, we can use those titles to call, or we can use those names instead of using white box testing, right? So, so what is the difference between, right, before that, the tester needs to have a look inside the source code, right? So tester need to have a look inside the source code and find out which unit chunk of the code is behaving inappropriately, right? So can you tell me major difference between black box testing and the white box? Okay, the tester need to have code-based knowledge to do the white box testing, but black box testing doesn't require that much of programming knowledge. Yes. Major difference between those two, in the black box testing, I told you that it's blind, right? So without having any knowledge of that particular system coding, you can perform black box testing. But when it comes to the white box testing, without having any knowledge of this source code of this particular system, you cannot perform that. For the black box, no need to look at the coding source code of the system. But when it comes to the white box, you have to take a look inside the source code of the system, right? So that's the major difference between those two. So we can have some techniques to perform white box testing. So first one is path testing, loop testing, condition testing, testing based on the memory perspective, test performance of the program. So those are some techniques that we can use to perform white box testing. So let's look at in detail, right? In the path testing, we will write the flow graph and test all independent paths. So let's say this is one of our program inside the system, right? So in here, you have to check this, each and every part. So with main, function A and function C. So then you have to check with main, function A, function D with the function E. Again, you have to check main, function A, function D with the function E. And after that, you have to check, function X with the H. So again, you have to check these parts. And also you have to check function A with the B and so likewise in this path testing technique, you have to go through each and every path in your particular system programs and you have to check one by one. So then you can give some values, sample inputs for for these functions and you can check. In main, you can give respective values for value to perform function A, then you can give another values to perform function A for the go to this path. Likewise, you have to give some values. You can give sample values, and you have to go through each and every. In the loop testing, we will test some loops like for loop, while, do while loop. We can test those loops during this loop testing technique. Here, what we are going to do is we are going to check for ending condition if working correctly, and if the size of condition is enough, right? So let's say here for this example, I have 50,000, right? So if you are going to perform this loop manually, it's not nice, right? It will take more time to perform this loop manually, right? So therefore, we can write a small program like this test P. This small program will help for all these 50,000 cycles. So then it will take some less time, right? That's how we perform loop testing. So basically we are checking with the ending condition, whether it is working correctly or not. And also we are going to check this size of the condition is enough to perform this. Then if this, so for this example, we are having large number of iterations. So if you are going to check this while manually, it will take more time. Therefore, we write a small program. This program will execute this 50,000 cycle without having that much how we are performing loop testing. So then next thing is conditional coverage. So in the conditional coverage, we will test all the logical conditions for both true and false value. So here I have two test cases. So this is my program. So here I have a condition. So A should be greater than 1 and B should be equal to 0. If these values are satisfying, so it's good here. It will perform this and it will come. Then it will check another condition, and if these conditions satisfied, it will go in this way and it will increment x value by 1 and it will come to the end. Otherwise, it will directly come to the end. So this is my program. So I have two test cases. So my A is equal to 2, B is equal to 0, and C is equal to 4, right? So let's let's assign these values. If A equal to means this condition is satisfied, right? So B is equal to means this condition is satisfied. So since these both conditions are satisfied, I can move to this part, right? So then I can perform this action x equal to x divided by A. So my x is 4 and x is equal to 2. So then I'm here. So my A is equal to 2. So it's here. And x A is equal to 2 or x greater than 1. So in this case, I'm satisfying both conditions, but no need to satisfy both. Then it can go this part. Then it will increment x value by 1. So my x will be 3 and 8. Right. So can you tell me my path? So I came here A and C. This is C. And I'll come to N by E. So my path is A to C to right. That's for the first. Right. So then I have another test case. A equal, so my A is equal to 1, right? A equal 1, right? So this condition is not satisfied, right? And B is equal to 0, that is also not. So therefore it will come here. Then this condition is also not. Okay, that is that. So A is equal to 0, A is equal to 2 is not, but X is greater than 1, okay, X equal 1, so which means it will go, right? So in this case, for this, we are having this part for this, and for this, I will flow A, B, D, A, and D, right? For this test case, my path is A, B, C, and for this test case, my path is A, C. So likewise, you can create some test cases uh, to go through each through path and also in the tools path, right? So is it clear about conditional coverage? So you can assign some values to go through. Yeah. So we are starting it here now. Without passing this, you cannot accept this. You cannot test this separately. So first you have to start here, then you can start and it here. So is it clear? So you can perform, you can declare any test cases to go through this. Is the third strategy condition for the testing. So third strategy is gray box testing. So it's a combination of white and black, right? So in color theme of, when we consider about the color, when you mix black and white, so you will get some gray color, right? So same as here, a technique to test the application with limited knowledge of the internal workings of an application. In software testing, the term the more you know better carries out a lot of weight when testing an application. Mastering the domain of a system always gives the tester an edge over someone with limited domain knowledge. Unlike black box testing, where the tester only tests the application's user interfaces, in gray box testing, the tester has access to documents and the data. Having this knowledge, the tester is able to better prepare test scenarios when making the test plan. So, if you have partial knowledge about the coding of this system, if you have partial knowledge of the internal working structure, you can perform this gray box testing. Basically, in the gray box testing, we are testing user interfaces. So when you are testing user interfaces, if you are going to pass some data in through your interface to the database, we are going to pass some data through your interface to data your database. It it is better if you can perform this test more accurately if you have some knowledge. So you have to know some coding, because when you're passing these two, if it is not performing well, you should be able to identify the bugs in your program. So if you have some idea about passing data one place to another, so then you can easily identify bugs in your program. So that's the thing when you're performing bug testing. So next thing is computing test coverage. How can we measure this test and coverage? To that, to do that, we have some concept that is cyclomatic complexity, or we can call it conditional complexity. So it directly measures the number of linear independent paths through a program source code computed using control flow graph of the program. The nodes of the graph correspond to the indivisible groups of commands of a program, and directed edge connected to connects two nodes if the second command might be executed immediately after the first command. And cyclomatic complexity may also be applied individual functions, modules, methods, or classes within a program. So I'll explain this using an example. So we have an equation to calculate this cyclomatic complexity, right? So I'll tell. Basis path testing is to test each linearly independent path through the program. The number of test cases will equal mathematically to the CC of the structured program. So this is the equation to calculate the cyclomatic complexity. E minus N 2 into P. This is the equation to calculate the cyclomatic complexity, right? So this E means the number of edges in the graph. So I'll show you. And this N means number of nodes of the flow graph, and this 2 is constant, and this P is the number of connected component, which means number of nodes that have exit point. How many exit points in your flow graph, right? So this is the equation. You have to remember this equation. So cyclomatic complexity is equal to E minus N plus 2P. So this E means number of edges, and N means number of nodes, and this P means number of exit points. Okay, so this is my example, right? So here, if A equals 10, then I have another condition. If B greater than C, then I'll assign A equal B, else A equals C, end of the if, and end of the first if, then I'll print A, B, C, right? So here you can see the graph. So if so I have a condition. I'm going to check whether A is equal to 10. So if it is true, right, this is true part and this is the false part, right? So if it is true, it will check this second condition. So B greater than C. If it is true, it will come here. If not, it will go then it will come to end and it will end the first condition, or if you didn't satisfy this condition at the beginning, it's end it and this it and it will print the ABC value, right? This is my program. So I want you to calculate the cyclomatic complexity. So you know the equation, right? So cyclomatic complexity is equal to HL minus naught plus 2P, right? So can you draw a flow graph using, I'll give you time to draw a flow graph, right? And calculate the cyclomatic complexity. I will give you 2K. What is the value for the cyclomatic complexity? This is my first node for the A. And then I have another node for the B, this condition. And I have another step, another two steps here. And end after that step, and again N4 and print it, right? So I have, so this node will connect with this, and this will connect with this and this, right? This node will connect with this, also will connect with this. After ending, it will end the first step and it will go to the O. It will come here directly and end the process, right? So this is my flow graph, right? So, right. So this is my first node, second, third, fourth, fifth, sixth, and seventh. Right. So how many nodes are there? We have 7 nodes, right? Right. So how many edges? 1, 2, 3, 4, 5, 6, 7, and we have 8 edges. So 8 minus 7 plus 2P. I told you that P means how many exit nodes. So in here we are starting with node 1 and we have only one exit file, so which is 7. So we have only one exit file. So 8 minus 7 is equal to 1 plus 2 into 1 is equal to 3. So cyclomatic complexity for this program is equal to 3. So is it clear? Is it clear about cyclomatic complexity? Tell me, how did you get 4? P means exit points. So in this program, we are starting with here and end with here. Now. So we have only one exit point. P means how many exit nodes. So how many exit nodes in this program? So here if you go either this way or this way, you have only one exit. This is my multiplication symbol, right? Okay, I will put it star here. So 8 minus 7 plus 2 into 1, right? That means CC equal to 8 minus 7 plus 2 into 1. So CC equal to, right? So here we have 8 edges, right? 1, 2, 3, 4, 5, 6, 7, and this one 8, right? We have 8 edges and we have 7 knots. 1, 2, 3, 4, 5, 6, 7. 7 knots, and 2 is a constant knot. So P means how many exit points. So this is our exit point. So we have only one. So the output is 3. So is it clear? Coverages are there. So function coverage, statement, decision. We discussed earlier about the function, statement, decision, conditional and decision coverages are there. So when you are going to have a functional coverage, here you are going to go through each and every function, or we can call it subroutine. So in your program, if we have three, let's say 3 functions, so you have to go through each and uh, every functions you have declared in your program to perform the function coverage. And in the statement coverage, so this statement coverage is we use it widely, and in here we have to go through each node in the program being executed. You have to assign some value, or you can have some sample data for sample data, and you have to assign those values into your program, and you have to go through the relevant path, and then you can calculate statement coverage. So then next thing is decision coverage. So here you have to go through each and every edges in the program being executed. And here let's say if your sample data satisfied through path, that means you are not going to go through the else part. So but when it comes to the branch coverage, right, so you are going to each and every branch, like here. So when you are going to calculate this cyclometric complexity, so you went through path, and as well the false path. So when it comes to the decision, so if you have assigned, so let's say if your a value is equal to 9, so in that case you are going to this part and you will end the program. So in that case you will consider executed nodes 1, 2, and 3, right? So that is the difference. That's why we are having that's why I have mentioned that this is decision coverage, not the same as branch coverage, right? So again, we can have condition coverage. We can call it predicate coverage as well. So in this coverage, we have to go through each Boolean sub-expressions evaluated both true and false. This does not necessarily uh, imply decision coverage. So those are some coverages we can see in the testing environment. So, but most probably we are using this statement and this decision coverage. And shortcoming of statement coverage, okay, without a test case, that force condition to evaluate false statement coverage rate. It's called fully covered. In fact, if condition ever evaluates false, this called false. This is the most serious shortcoming of statement coverage. If statements are very common, so we know that, and statement coverage does not report whether loops reach their termination conditions, only whether the loops and in the loops like do while loop, so it's always execute at once. So when you are going to consider about the statement coverage, so we can rank them as non-branching statements. So we can take it as a one thing. And also statement coverage is completely insensitive to the logical operations like O and AND. So those are the things that I want to discuss about the testing part. So then I'll move to the next part, software maintenance.